In this video, we're going to talk about SASSy system stability. This is a topic that people may not think about too much, but it's actually quite important. But first, I want to introduce you to a package called pkgdiff, and this will help us examine this topic. Here's the package, pkgdiff, and what this package does is collect information on packages. It goes out to the CRAN archive, pulls down archived versions of packages, and compares them, and collects data on those comparisons. And so what I'm going to show you is a function called package summary, and let's just run this on a very popular package in the Tidyverse called Tibble. And you can see what this function does is create a little report, the package summary report. Gives us the name of the package, the current version, the stability score, who's the current maintainer, how old it is, when was the first release, when was the last release, how many releases there have been, how many of those were breaking, the total number of functions in the package, how many downloads it gets per month, and then its dependencies and imports. The most interesting part of this report is this little chart at the bottom. And what this is showing us is the breaking changes for the whole history of the package, or most of the history of the package, at least the last 10 years. The x-axis of this chart is each release. So this is the release from August 2017, version 1.3.4. And you can see that between this release and the next release, version 1.4.1, in December of 2017, there were about 16 functions removed and maybe another 5 or so parameters removed between those two releases. That means that these removals could potentially break your code if you happen to be using them. And when I look at this chart, what I see is a lot of removals here early in the development of the package, and then a few in the middle here, and then this long period of recent history since 2021 where there's been almost no breaking changes. And so that's quite good, positive for the people who are using this package. Let's go look at another package. This is Tidyr. This is another very popular package. You may not be aware of it. The functions in this package, many people think they're from the dplyr package. This includes the pivot wider and pivot longer functions, plus nest and a few other interesting functions. This is a very stable package according to this report, and it's only had 8 breaking releases out of 31. It gets a lot of downloads, 1.5 million downloads per month, and you can see not too many functions or function parameters removed from this package over the last 10 years. It's quite an old package. First came out in 2014. One thing I'd like to mention is this stability score, how this is calculated. Overall, this is the number of breaking releases divided by the number of releases, and that comes up with a percentage. And one little factor in here is that those breaking releases are weighted over time, meaning that as the breaking release ages, as new releases come out and the breaking release goes back in time, it counts for less. And these breaking changes will age out of the stability score after about 8.5 years. What this chart is showing us is the last 10 years. And so this 23 functions removed is either aged out of the system or about to age out of the stability score. Let's look at one more package, probably the one that everyone is interested in. This is dplyr, and anyone who's used this package knows that it's had some breaking changes. There were a lot here in 2020 for version 1. And what had happened, if people remember from that period, was there was a lot of deprecations in the prior period, and you were getting warnings saying this function is about to be deprecated. And then when POSIT switched to version 1, they removed all those functions that had been deprecated, and there was quite a lot of them. There was 70 or so functions removed and a few parameters. But I'd also like to point out that since then, the number of breaking changes has come down a lot. And I want to point out further that this package has not even had a release since 2023. It's now December 2025, and so it's been over 2 years since this package has had a release at all. And so that's also quite good for the people using this package. That means that the developers seem to be happy with the functions they have, the names of their functions, the names of the parameters, and this package has stabilized quite a lot in the last few years. So that is the package summary report from pkgdiff. So now let's go look at the r-sassy system. How does the r-sassy system appear on this report? So the first one I'll run here is the r-sassy package itself. And you can see that this package has had 13 releases. It's had no breaking releases for a perfect stability score. And I'm going to look at another package. This was actually the first r-sassy package and predates the r-sassy system itself by about 8 months. The logger package also has a perfect stability score. It's had 23 releases, none of them breaking. Here's the common package. Common package, also perfect score. Here's the formatter package. Oh, this one's actually had 2 removed functions in 2022. And what happened here was that 2 functions were removed from this package and put in the common package, and then a dependency was created on the common package. You can see that dependency right here, which means those same functions that are now in the common package, because it's a dependency of this package, would have flowed through and appeared to the user as if nothing happened. So strictly speaking, it was a removal. From a practical perspective, it didn't affect any users. Another package, libr. Also, one removal, the exact same thing happened again. There was one function in this package that got moved to the common package, and then a dependency was created on the common package so that it wouldn't affect any users. Prox package has had no breaking changes. The reporter package has had 1 parameter removal in 2023. This function, the parameter, is on a function that's strictly speaking exported but not really used by users. It's kind of a developer function. So this also very likely did not affect anybody. And then one more package in the r-sassy system. This is the macro package. This has only had 1 release and therefore no breaking releases. So you can see that overall this is an extremely stable set of packages. If we were to summarize the information from that package summary report into a table, it would look like this. So here's a package on every row and the total number of releases for that package, and then the number of breaking releases for that package. Overall, the r-sassy system at this point in time has had 114 releases. 3 of those were breaking, for a breaking release rate of 2.6%. That means that every time a r-sassy package is released, you have a less than 3% chance of getting a breaking change. And that is extremely good. So what you might ask next is why? The whole idea of the system is to take good ideas from Sass and bring them into R. And one of the ideas that was brought from Sass is stability and backward compatibility. Those are very valuable in SAS. The users of the SAS system really appreciate that. And so we would like the same kind of stability in R, and that's what the SASSy system is intended to provide. That stability and backward compatibility is helped by thoughtful design of the system. So when the packages are designed, the developers think through it very carefully, choose their names of their functions and parameters very carefully, and furthermore, try to think forward to what future changes or enhancements the package might undergo and design the functions in a way that it can accommodate those future changes. SASSy packages also have long shakeout phases. That means that after development is done, there is quite a long time where the developers use those packages in sort of a realistic situation. And they not only find a lot of bugs, but they can make a lot of changes to the design. If the functions don't flow well, they will be changed. If the names don't make sense, they will be changed. And the package is not released until that shakeout phase is done. That means there's less reasons to make changes once the package has been published. And all of this thoughtful design and long shakeout phase is greatly facilitated by the fact that the developers of the system are under no deadlines at all. Every contributor to the SASSy system is a volunteer. They're not doing this as part of a corporate initiative, which means there's no executives breathing down our necks, asking us to release things by this certain date. If they need to delay the release of a package for 2 months because they're not happy with it, they will delay it. The most important thing for the SASSy team is to get the package right, get the functions right, and that's really the only thing that matters. So that is a few comments on stability of the SASSy system.